All right, well, this is a little overview of some of the questions off of the Chapter 3 review. Again, a lot of this information that you will see here will also be on the test, so it's going to be some good detail. Also, it'll be a good way for you to kind of look back, and if you have a question about something, you can just rewind the video. And I know I talk really fast, so it's good to kind of rewind the video, get an idea of what's going on, and then hopefully this will be a good way to prepare you for some things you're going to see later on, and some of the things you will need to remember. And hopefully it builds your understanding on the topic as well. So, here we go. Chapter 3 review. Let's dive right in with the first set of questions. First of all, identifying congruent angles on parallel lines. Okay, so how and what angles are congruent? Okay, so that's what we're trying to figure out here. You do see you have two parallel lines. EF is parallel to GH. And you also have this transversal SR on this graphic here. You have a certain angles that are numbered here, okay? And as you know, based on some of the discussions that we have had, these angles have some relationships in terms of congruence or their ability to be supplementary to each other, right? So, first things first, you guys recognize that some of these angles are corresponding angles, okay? That's one of the first things you're asked to identify. So, angles that are corresponding. Let's actually get our little handy-dandy pen out here, if I can draw some pictures here. Boom. Alright, so let's draw. So, corresponding angles, again, let's take a look at example. For example number 1 is a corresponding angle to number 5, okay? They are on the same side of the transversal and kind of on the same corner of each parallel line. That's why they're corresponding. They're kind of in a related situation along the same transversal. That makes it a corresponding angle. You also have, here, let me change colors here. You also have alternate interior angles. So alternate interior angles are on alternate sides of the transversal, and they are also on the inside. Okay, that's alternate interior angles. Okay, so for example, angle 3 and angle 6 are alternate interior angles on the inside of the parallel lines and on outside of the transversal, and then same with angles 5 and angles 4. Those are also alternate interior angles, okay? Now, alternate exterior angles, okay? Alternate exterior angles, they are on the outside of the parallel lines, but on the opposite side of the transversal. So similar to alternate interior, just on the outside. Angle 7 here would be an alternate exterior angle to angle 2, okay? Because they're on the exterior, opposite sides of the transversal, okay? Angle 1 and angle 8 are also alternate exterior angles. Let's erase the screen real quick so we can get a little bit more. Alright, so now consecutive interior angles are unique in that they are ones that are not congruent, okay? So all of these ones, corresponding alternate interior, alternate exterior, all of these ones right here, these ones are congruent, okay? Unlike consecutive interior angles. Consecutive interior angles have the fact that the sum of them is equal to 180 degrees. So they are supplementary. I'm just going to put sup because that's a little bit too much to write on a screen right here. But supplementary, okay? So supplementary means that the sum of their angles is going to be equal to 180 degrees. So consecutive interior angles are on the same side of the transversal and on the inside. So angles 5 and 3 are consecutive interior angles. Angles 4 through 6 are also consecutive interior angles, okay? So all of those, again, are consecutive interior angles. So these relationships you do need to know, you need to be familiar with, okay? That is kind of how they are drawn out. So now, with an understanding of these different relationships, you can then identify how the degrees are on these angles, okay? So, for example, if measure of angle 3, let me get my laser pointer out. If measure of angle 3 is equal to 115, find the measure of angle 6. So, for example, measure of angle 3 and angle 6, they are alternate interior angles. So that means the measure of angle 6 is also going to be 115 degrees, okay? It's also 115, right? If measure of angle 3 is equal to 110, find measure of angle 7. Now, 3 and 7 are also congruent because they are corresponding angles, right? Corresponding angles are congruent. So that means this is also 110. 10. Okay, measure of angle 8 is equal to 62. Find measure of angle 1. Measure of angle 8 is right here. Okay, so that's 62 degrees. And measure of angle 1 is over here. That makes it an alternate exterior angle, so that means this one is also congruent. 62 degrees. Okay, measure of angle 2 equals 130. Find measure of angle 5. Now, these ones are not congruent. They are supplementary. Why on earth is that the case? Well, angle 2 right here, okay, is a corresponding angle to number 6, which is supplementary to 5, okay? And since we can determine that to be the case, this is going to be 180 minus 130, which is 50 degrees, okay? So knowing these relationships right here is pretty important and will be key to things that we do later on, okay? So, next thing, okay? Finding values given angles as expressions. All right, I'm going to pull out my dot cam for this one. Here we go. Okay, so this is one of the problems that I gave you guys also as well. But you can see the drawing right here, okay? This angle right here is 62 degrees, okay? And then this angle right here is 5x plus 8. Now, one thing to first notice is to identify what relationship these angles are in. Okay, first one here is right next to this one. They're on the interior on the same side of the transversal. So we know that these are consecutive interior angles. Okay, which means the sum of the angles equals 180 degrees. Right? So you can use that as your example. Now, looking at those two angles, then I can determine, okay, which means that 62 plus 5x plus 8, the quantity, equals 180 degrees. Why is that true? Well, because these angles are consecutive interior angles, right? And we're just substituting in now. So let's solve for x. 5x, 8 plus 62 gives me 70, equals 180. Subtract 70 from both sides because we're solving the equation now. 5x equals 110. Divide both sides by 110, and that should give you roughly 22. If I remember correctly. Yes, x equals 22. So that is how you solve that particular situation. Now this one, similar setup, but again, notice the relationship between the two angles. 2x minus 6 and 54, they are corresponding angles. Okay, so corresponding angles, if you remember correctly, corresponding angles are congruent. Okay, since that's the case, then we can use that to solve these problems. So 2x, the quantity 2x minus 6, plus 54 equals, oops, did you see my mistake there? I just told you they're corresponding angles. 2x minus 6, the quantity is equal to, sorry, man, I'm definitely having a little bit of a shake up here, equals 54. That is your equation. Okay, so now we solve for x. So we're going to add 6 to both sides first. Okay, that's 2x equals 54 plus 6 gives me 60. Divide both sides by 2. Therefore, x is equal to 30. And that is, in fact, the correct answer. Okay, so be careful when you're differentiating between angles that are congruent and angles that are supplementary. I made the mistake myself. See, it's a pretty simple mistake to make. But again, identifying those relationships is a big deal when it comes to figuring out those solutions. All right, next one. What conclusions can you make about this figure? Okay, that's what's being asked here in these problems. All right, so it's basically asking you to tell me whether you can prove lines parallel based on this information, or if you can prove that they are neither parallel, or if you can't prove anything at all, or if you can prove both are. Okay, that's what it's asking here. So first of all, if you see angle 4 congruent to angle 8, first of all, angle 4 is right here, and angle 8 is right here. Okay, these are attached to this line M. Okay, and since they're attached to this line M, that means M is our transversal here. Okay, and P and Q are the lines that we're trying to determine something with. So angle 4 and angle 8, you can see, are corresponding angles. And if those angles are congruent, therefore that means that our solution for this situation is that P is parallel to Q. Right? Because they're corresponding angles. Corresponding angles and parallel lines are always congruent. Okay? So angle 2 is congruent to angle 11. Now we're on some different ones here. Okay, so for those ones, we got to identify where they are at. Angle 2 is right here. Angle 11 is right here. The line that they're both attached to is this line right here, line P. Okay, and since they're attached to this line, then we can determine that to be our transversal, which means 2 and 11 are alternate exterior angles along these lines M and N. And since they are congruent, we can then conclude here, I'm gonna write it here, that M is parallel to N. That's the solution to that one. Okay. Number 10 is angle 2 is congruent to angle 14. Okay, so we'll identify where angle 2 is. It's right here. Okay, angle 14 is way over here. Can we do anything with those? No, we cannot, because they are not on the same transversal, and they're on opposite sides of this figure. Okay, so again, if they're not attached to the same transversal, we can't make a conclusion. So they're way separate from each other. So that means we're going to be dealing with neither are parallel based on that. Okay, so now number 11. Okay, no, angle 3 is congruent to angle 10 is congruent to angle 15. So basically we have 3 angles that we can use here. If angle 3 is congruent to angle 11, okay, that means we can conclude that that M and N are parallel, since these are corresponding angles and they're all along the same transversal. M is parallel to N. That's not it, right? Because we still have angle, oh, I made an error here. Okay, so angle 3 is congruent to angle 10. They're alternate interior angles. Sorry about that. Angle 3 and angle 10, alternate interior angles. And then angle 15 is an alternate interior angle, right? So since these two are alternate interior angles along transversal N, that means P and Q are also parallel, because again, alternate interior angles along parallel lines are congruent. So that means P is also parallel to Q, so both is in fact the answer here. Okay, new page. So again, being able to identify those, big deal when it comes to this. So let's move on to the next one, shall we? Oop, kind of move my next slide. There. All right, so proving angles from parallel lines. All right, so you see, this is a proof. Again, you guys know that proofs, you're required to justify every single thing when it comes to how you're trying to, well, make something to be true. Okay, it's deductive reasoning. Okay, not necessarily, can't really have anything speculative with that. Okay, so we have our statements here and reasons here. Now looking at it, you could probably just determine that, yeah, angles 1 and 4 are going to be supplementary. But when you're justifying it in terms of a geometric sense, it's important to be able to have your statements and reasons listed for you. And I think it gave you some too. You are given P is parallel to Q with transversal T. I'm just going to put TV, T. Okay? But that's transversal. That represents transversal. Okay? And that's what's given to you. Okay? So your next step here, again, you're trying to reach the point where angle 1 and angle 4 are supplementary. And you know that P is parallel to Q. Alright, well, looking at P and Q, okay, I need to find some way to get to the point where I can determine that angles 1 and 4 are supplementary. Alright? So, I would need to find some angles that have a relationship with 1 that are right next to angle 4, because that's what I need to work with. I need to work with angle 1 and angle 4. Now, I notice here that angle 1 is right here, and angle 3 is right here, and those are corresponding angles. And since I know P is parallel to Q, and they're corresponding angles, I can say that they are congruent. So that is my first step. Angle 1 is congruent to angle 3. Okay? And that is due to the corresponding angle postulate, or in these terms, cap. I like calling it cap. It sounds nicer. Anyway, so step 3. Alright, so when you determine something to be congruent, a good step to always go to is to also say that they're equal in measure. Measure of angle 1 is equal to measure of angle 3. Why? Because that is the definition of congruence, right? So again, we're justifying every step as we go down, but you can see that measure of angle 1 is equal to the measure of angle 3. Alright? What else do I notice now? I need to connect this to angle 4 somehow. Alright, so angle 1 is equal to angle 3, but angle 4 hasn't been messed with yet. What do I notice about 3 and 4? Well, I notice that 3 and 4 are in fact supplementary. Why can I say that they're supplementary? Well, it's pretty easy to tell that they form what is called a linear pair, adjacent angles that are along a straight angle. They form a linear pair, which means that I can say that angles 3 and angle 4 are supplementary. Why? Linear pair. They form a linear pair. And since they form a linear pair, now you might be able to see where this is going. Okay? Because now that I know that 3 and 4 are supplementary, okay, and I know that angle 1 is congruent to angle 3, I have to get to the point where I just have to substitute angle 1 for angle 3. And the way I do that is then I also go to the fact that since these are supplementary, that means that measure of angle 3 plus measure of angle 4 equals 180 degrees. Okay? And that's the definition of supplementary. Right? So, definition of supplementary, that is where we are. Now, once I'm there, I can then go to the fact that I can substitute measure of angle 1 plus measure of angle 4 equals 180. Okay? I substituted. And then the last thing is that angles 1 and 4 are supplementary. Okay? Definition of supplementary allows us to do that. So again, those definitions are important to be able to use and apply in a deductive reasoning situation such as this. Okay, let's move on to the next one. Another proof here. Okay, given P is parallel to Q and M is parallel to N, tell me how angle 8 is congruent to angle 9. Now this one actually is only a 4-step process. Okay? So again, always good to kind of go with it this way. And there's other ways to prove. You can use paragraph proofs, but again, kind of the process we're going through is the 2-column. All right, so first step here, P is parallel to Q. Okay, we are given that information. Why would we start with P is parallel to Q? Well, first of all, what are we trying to get to? Identify our end goal here. Angle 8 is congruent, or angle 8 and angle 9 are on P and Q, okay? So they are both on P and Q, right? So that's something we can use to help us. First of all, there's actually multiple ways to do this, but I'm gonna try to use just P and Q, the fact that they're parallel, to prove that angle 8 is congruent to angle 9. So again, I am given this information, right? So if I know that P is parallel to Q, how can I get to this point? I can see that, first of all, angle 8 and angle 4 are, in fact, congruent. Why? Because they're corresponding angles. So I'm going to do that. Angle 8 is congruent to angle 4. Why? Corresponding angles. Okay? So since those are corresponding angles, I can then go from there to see if I can get to the point where 9 is congruent to that, which in fact it is, okay, since I know that M is also parallel to N, right? Angle 8 is congruent to angle 4, and then I can also say that angle 4 is congruent to angle 9, because they are also alternate interior angles. Okay, since they're alternate interior, then we can simply just go and apply the transitive property here, because again the transitive property says if A equals B and B equals C, therefore A equals C, right? So we have 3 angles here. Angle 8 is congruent to angle 4, angle 4 is congruent to angle 9, so therefore it's pretty reasonable to say angle 8 is congruent to angle 9. Okay, transitive, that is the transitive property. All right. I think there's a 2-column proof you guys will have to do later on, so you'll want to keep that process in mind. But that is a 2-column proof of that. All right, so this is what we got to after proofs. Okay, we talked about finding distances amongst 2 points, and I know points is cut off from my screen there. So anyway, finding values amongst 2 points. So find the distance between each pair of points. So if you're identifying a distance here, let's first of all plot our points, shall we? Probably a good idea if we're going to be looking at this. So let's plot 3, 2 on our graph. So you have 3. It goes again, when you're plotting, hopefully you can see my red dot on the screen. But when you're plotting, you start with the x-axis first for an ordered pair. Your ordered pair is 3, 2. So that means we're going to go 3 to the right and 2 up. And what is that? That is 3, 2 right there. Okay? Now we also need to find 9, 10. So 9, 10 is a little bit further out, but we're 9 on the x-axis over here, and 10 on the y-axis, so let's draw that here. Okay? So then, the goal here is to find the distance right here. Okay? So there's a couple ways to do this. One is you can count this direction, okay? And you can also count this direction up to find the value vertically, okay? And use the Pythagorean theorem to do it. But there is a simplification of the Pythagorean theorem that enables us to make it a little bit faster. But you guys could probably see that this is 1, 2, 3, 4, 5, 6 units, 6 blocks, okay, on the graph. And then this one goes up from 2 to 10, so this is 8. So you could use the Pythagorean theorem, but technically what you're looking for here is you're looking for c, right? Okay? And since we know that a squared plus b squared equals c squared, okay, we could actually just simply take the square root of both sides, and then we could easily find c by simply taking the square root of a squared plus b squared, right? Okay? So that's one way you can do it. You can use the Pythagorean theorem here. But again, the way that we were using in class, which makes sense when you put it together, if you're just given 2 points and you're not even given a graph, all you have to do is you can simply find the distance by taking the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. This right here is the distance formula. Okay? And this actually is an adaptation right off of this. Doesn't it look familiar? Because you have a squared, which is x2 minus x1 squared, b squared, which is y2 minus y1 squared. So this is basically this, just using the ordered pairs and the values for that. So d equals square root of, I'm going to use the ordered pair up here, 3, 2, and 9, 10. Okay, so that means I have 9 minus 3, quantity squared, plus 10 minus 2, the quantity squared. Woohoo! Okay, so distance equals square root of 9 minus 3 is 6, squared is 36, plus 10 minus 2 gives me 8, 8 squared is 64. Putting that together, I have square root of 100. Therefore, my distance is 10. So that means C equals 10. All right? So that's how you use the distance formula. Now we can also find some other values, okay? Midpoint and slope, which will be values that you will have to know how to find also. But let's erase our ink here. All right, so finding the midpoint of 14, negative 3, and negative 6, 21, okay? So the formula again for finding the midpoint here is you have to just add the two values together, x1 plus x2 divided by 2. That makes sense, right? Because if you're going from one x value to another x value, if you split it in half, you're going to be in the middle of that. Same with the y values. Okay, that's midpoint formula right here. So let's apply it, shall we? 14 minus 6 over 2. And then negative 3 plus 21 over 2. 14 minus 6 gives me 8, if I'm not mistaken. Yeah, I think it's 8. 8 over 2, which is 4. And then negative 3 plus 21 gives me 18 over 2, which is 9. So the value here is 4, 9, and that is how you express your answer as an ordered pair. All right, so that's the answer number 25. 27, finding the slope. Again, remember, key point to make here about slope. Slope is equal to the rise over the run. Okay, so the rise over the run. So let's actually plot this in the graph here. So you have 3, 6. Okay, 1, 2, 3, 6. Okay, so I plotted 3, 6. Let's plot 6, 0, which is right here. Let's draw my line. That is a very sloppy line. I'm sorry about that, but it's a line. Anyway, so you have 3, 6, and 6, 0 here. All right. Now, one thing I can easily determine already from this graph is that 3, 6, this line, is negative. Okay? It's a negative slope. Why is it a negative slope? Well, notice the line is going downwards from left to right. Okay? It's going downwards from left to right. How do I determine that algebraically? Well, and then we'll compare it to rise over run here. But the way you determine the rise, again, is use the y values. Because again, y values rise and fall, right? So y2 minus y1. And then you have the run. The run, again, where is it running to the left or is it running to the right? So again, it makes sense that the x values are on the bottom. y2 minus y1 over x2 minus x1. That's how you do it, algebraically. So let's plug in our y values. Okay, again, your y values here, you have, let me pull out my laser pointer. y2 would be this value right here, because it's your second point with a y value. And then 6, this is y1, x2, and this would be x1. Right? So, that means y2 minus y1 over 0 minus 6 over 6 minus 3. Right? Then I can just go negative 6 over 3, which m equals negative 2. Hey, look, negative slope, just like I thought. So, the prediction here with this slope, all right, would be that as the rise decreases to 1, 2, it'd go over 1. Now I know my graph looks pretty garbage, okay? But this is actually where the line would be, okay? Because you're going down 2, over 1, down 2, over 1, down 2, over 1. And look, I winded up at that point that I made just a little bit earlier. So the line would look a little bit more straighter like this. It'd probably be a better representation of the true value of the slope. But still, hopefully you can kind of get the idea based on what is being shown there. So, let's move on to our next set here. Whoops, did not mean to go that far. Alright, so identifying slopes from a graph. So if you're given a graph already, finding the slope, there can be several ways by which you do this, okay? Again, if you're finding the slope of wx, for example, this segment here, okay? You could just count the rise over the run, right? Because m, or the slope, is rise over run. Alright, so let's calculate the rise here. Rise, right here, w, you're going down 1 over 2. Okay? So down 1 over 2 means that my rise is negative 1 and my run is 2. So I would guess that my slope is going to be negative 1/2 based on just looking on the graph. Now, I can also determine it algebraically, which I'll do that real quick. M equals y2 minus y1 over x2 minus x1. Okay? I have my point W. I see that point W is on negative 1, 4. Alright? Negative 1, 4. And I see that my x point is at 3, 2. So that means I could just plug these in. So let's do it. M equals 2 minus 4 over 3 minus a minus 1. Now that I've done that, I just combine negative 2 over 4, which is the same thing as negative 1/2. These are exactly the same answers, determined two different ways. So you can do it just by eyeballing it if you have a graph, or you can use the algebraic way still. It still will work. All right. Which segments are perpendicular? Now, in order to figure this out, we actually have to determine the slopes of all the other ones. So I know that the slope of wx is equal to negative 1/2. Okay? Remember that perpendicular lines have slopes that are negative reciprocals. So that means we would predict that our slope for a perpendicular line to wx would have to be not negative 1/2, but positive 2. Why? Because that is the reciprocal of this fraction, and it is the opposite. Okay? So let's find them. Let's go xy. Oops. Wah, wah. xy, yz, and zw. Okay? So let's take a look at xy, shall we? Notice that this line, again, if it's going upwards left to right, that means it's going to be a positive slope. This right here has a positive slope. You might be tempted to go down 2 over 1. You're going, the run is always going to go in this direction. Okay? So that means you want to start at y when determining the slope here. So let's do that. Okay? Up 2, that's our rise, over 1, up 2, over 1. Okay, you can see that an ordered pair is attached to this point here, so you can just go from here and say, I'm going to go up 2 over 1. My rise over run is 2. So that means we can say that Wx is perpendicular to xy, because this is the negative reciprocal of this slope. Now let's take a look at zy. Okay, you see zy right here, going down 1 over 1, 2, 3, 4. Okay, and you see that it's going down and over, which means the slope of yz is negative 1 over 4. That's not the negative reciprocal, and that's not the same slope as any of these. So that one's unique, its own thing. Now z to w, you go up 1, 2, 3, 4, 5 over 2. The slope here is 5 over 2. So that means the only lines that are perpendicular are wx is parallel to xy, and there is in fact no parallel lines in this quadrilateral. Makes sense too, because it's a quadrilateral. And if it was a perfect quadrilateral, we'd have parallel lines, but we don't have any of those. Alright, so that's that one. Next, graphing equations. Okay, so again, when you're graphing equations, there's multiple ways to do this, okay? But 34 asks you to graph by finding the x and y intercepts. So how do you find the x and y intercepts? You go 3x minus 4y equals 12. That is our equation there. So the way to do that is, again, if you're trying to identify the intercepts of, like, for example, the x-axis, okay? So the x-axis is right here. What does y equal on the x-axis? Equals 0, right? It's not going to be going up or down on the y-axis if it's touching the x-axis. So that means 3x minus 4, and if we plug in 0, we are now finding the value of x that would be on its axis. So that means 3x equals 12, therefore x equals 4. So that means I know if x equals 4, I have a point on here. Let me graph it real quick. At 4, 0. That's 4, 0. Okay? Now to find the y-axis, again, x is going to be equal to 0 on this y-axis right here. So that means I set x equal to 0. So let's solve for y. Negative 4y equals 12. Divide both sides by negative 4. Inverse operation. Y equals negative 3. Ta-da! So that means that my y-intercept is at negative 3. And then it comes down to simply drawing a line, which again is that very simple. Not for me because I'm not an artist. Ta-da! Anyways. You'll have a straight edge probably that you'll be able to use to graph these a little bit more easily when you do it yourself. But that is how you would graph that one. Okay. Now let's clear it off and let's try slope-intercept form. Okay. Slope-intercept form again is set up always such as y equals mx plus b. Okay. Y equals mx plus b. M is your slope. B is your y-intercept. Okay. So, if you know that y equals 3x minus 1, I know that my slope is 3, and my y-intercept is at 0, negative 1. So, always start, when you have one of these, by plotting your y-intercept. So that's what I'm going to do. 0, negative 1. Right there, I need to get my pen out. 0, negative 1, right here. Okay. Then, I know that my slope is 3, so I have to go up 3, 1, 2, 3, over 1. My rise over run is 3 over 1. That rhymed. Because as a poet, I didn't even know it. Check it out. I draw my line. There you are. Missed the point, but that's the point of the matter. Alright, next. 2x plus 3y equals 9. Okay. Now, again, if you have something like this, but you want to use slope-intercept form to graph it, you have to solve this equation first for y. So 3y equals negative 2x. I subtracted 2x from both sides, plus 9. Divide everything by 3. 3's cancel on the left side. Therefore, y equals negative 2 over 3x plus 3. That's your slope-intercept form. So let's graph that real quick. Okay, so I know that my y-intercept is at positive 3, so I'm going to put that on here, 0, 3, because my b is 3. Okay, so then now my slope is negative 2, 3. There's a negative here, so that means it's going to go down for the rise, then over. Down 2 over 3. Then I can draw my line. Wow, perfect. Not really, but you know. So, there is my graph of that equation. Okay? Now it says find the x and y intercepts and slope of 7x plus 3y equals 21. Okay? So that means we actually have to graph it and then use that graph to identify the slope. So, let's do it. 7x plus 3y equals 21. Okay? 7x, right here. Again, if I want to find my x-intercept, I have to set y equals 0. So if y equals 0, that means this whole term gets eliminated. 7x equals 21. Therefore, x equals 3. So that's my x-intercept. My y-intercept is going to be 3y equals 21. Therefore, y equals 7. Okay, so now I know where my graph is. So then I'm going to go and graph at 0, 3. And then at 7. 1, 2, 3, 4, 5, 6, 7. So how would I find the slope after just having these two things? Well, I could do it algebraically because I know that my x-intercept is 3, 0, and my y-intercept is 7, 0. But we can also do it in a much easier way just by looking at the graph we just made, right? So let's take a look at this point here. And then let's do our rise. Our rise is going to go down, so it's going to be a negative value. 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. Okay, so that means that our slope is negative 7 over 3. Okay? Negative 7 over 3. That is our slope. All right. We're going to move on to one more, and then we'll wrap this thing up. I know this is a very long video. It's just like, stop. My brain hurts. Finding equations of lines. Okay? You do need to be able to do this, so we're going to go through the process in a little bit of detail. All right? How to find equations of lines. I think I gave you guys one of these when I signed it. But you see this graph right here on the bottom right-hand corner. All right? Now, what you're doing here is you're looking to find the equation of line parallel to C through point A. Okay, there's a couple ways to do this. You can use different points, but the point that I'm going to use, I think, with this is I want to find, again, first of all, refresh what I just said. The first step in doing this, okay, is to identify point A. All right, what is point A? Point A sits at 4, 1. Notice how it's 4 units to the right of the y-axis and then up 1. So it's over 4, up 1. That's where A is. Okay? And this next step here is to identify the slope of C. Well, let's do that the easy way, right? Let's pick a point where it's crossing, right here. And let's find a different point. There's another point down here. So we're going to go down 2 over 1. It's going down, negative direction. So if it's going down 2 over 1, that means my slope is going to be negative 2. Okay, that means the slope of the new line that I'm going to make also has to be negative 2 because it's a parallel line. Slope of the parallel is going to be negative 2. Okay, so that means I use y equals mx plus b, slope-intercept form, and what I have to do here, and what I have to do for pretty much any line I have to find, is take my point, take my slope, plug it into here. And I do not plug in for b, I'm solving for b. Okay? So y is 1 equals negative 2 times 4 plus b. Now I'm solving this equation for b. What I'm doing is I'm finding the y-intercept of a line that goes to the point 4, 1 with a slope of -2. That's what this equation represents right here. So now, let's solve. 1 equals -8 plus b. b equals 9. Okay? Now that I know my y-intercept, I still know my slope. Right? So my slope is going to be y equals -2x plus 9. That is the slope of a parallel line that goes through point A. What if we want to find a slope that's find one that's perpendicular? Well, it's pretty straightforward, because what is going to be the negative reciprocal slope for that perpendicular line? If your parallel slope is -2, your perpendicular slope is going to be the negative reciprocal, which is positive 1/2. Okay? So I do the same thing, just with the new slope. So that means I do y equals mx plus b. Okay? My y is 1. My slope is 1/2. And my x is 4 plus b. Therefore, 1 equals 2 plus b. Therefore, b equals -1. Okay, I have -1 here. So that means my new equation is going to take this slope, this y-intercept, and plug it in. 1/2x minus 1. And that is how you find parallel and perpendicular lines when they're passing through a specific point. Okay? That's kind of a rundown of a lot of different topics that you have in this topic. Okay, so good things to note. And again, you will want to remember these for the future. Hopefully this was a helpful video, and hope you're ready for that upcoming test. Later.